Then editor does not have its open. Why is absurd? It's yellow. Sequence with water and a testing. Precipitate excess observed. Excess observed. Excess concentrated ammonia is then added to the testing. After the test tube has been shaken, precipitate rise observed. B, I think.
B is in boy?
Yes.
No. What if I tell you both A and B are wrong? Nothing about X is correct over here. What would you choose then?
Y is pure silver chloride. Y is yellow. Has been shaken, a precipitate is observed. Precipitate silver AgCl2.
So silver chloride. C.
I think D.
Sat says C. And you said? Can you hear me now?
Yes, sir.
Sorry, a little bit of internet issue. It's happening today a lot. Okay, so Saad said C and you were saying something?
D.
D. Okay, let me tell you D is correct. Let's discuss how. Now, first of all, we get a precipitate. Actually, we get a couple of precipitates. We get a precipitate with chloride. We get a precipitate with iodide. This one's white, and this one is pale yellow. We can simply call it yellow. Now, what's going to happen when we add excess concentrated ammonia, that this white would be converted into a colorless or transparent solution because this dissolves and forms a complex. So since it does that, it's not going to be, X is not going to be a precipitate. So no, it's not silver iodide. It's actually a complex. No, this one is silver iodide. So no, this can't be silver chloride. And this one is yellow. And why do we still have this one? Remember, the yellow precipitate, or simply speaking, silver iodide, do not dissolve further in excess concentrated ammonia, no matter how much amount you use. So D is the only one that is correct. Okay, I hope that clears it out.
Yes, sir.
Good. Moving on. 2.
The addition of aqueous silver nitrate to aqueous barium chloride produces a white precipitate which dissolves in this dilute aqueous ammonia to form a colorless solution. The addition of excess dilute nitric.
This is too easy. I just told you that. So you're gonna jump right off with A, silver chloride as the colorless white solution. So you already know. Let's not do this. It's too easy. Okay. Let's see what we have next. So yeah, this one is a good one. Let's go with 3.
How does concentrated sulfuric acid behave when it reacts with sodium chloride?
Notice how many times it has been repeated. It has
That's
been
true.
probably a part of papers even before 2010, but that's all we can see over here.
See, and sodium silicate. No, sorry, not sodium silicate. Sodium sulfate plus HCl. So -2 plus 1. Yes. I think A, because redox reaction नहीं हो रहा.
Saad,
Just a minute, sir.
sorry, I didn't get that.
Just a minute, sir.
Take your time, sure.
So I also say A.
Right. So if this question was a little bit changed, you're correct. You both are correct. It's just acting as an acid. What if we were talking about sodium bromide or sodium iodide? What would you choose then?
Reducing agent.
What about you, Saad? Can you hear me now?
Yes,
Yes,
sir.
sir.
Okay, but again, the internet. Okay, so coming back to it. Yes. Saad, you were about to answer it. So,
So I said D.
D. You both chose
As in
D.
beta.
D as in door.
Yes, sir.
Okay. No, that's not correct. It would be B. B as in boy. At first, it would act like an acid and it would definitely produce either HBr with sodium bromide or HI with sodium iodide. But later on, it would start acting as an oxidizing agent and hence it would produce bromine out of HBr or iodine out of HI. So it would be beta if it was sodium bromide or sodium iodide as a part of the question. So moving on, number 4.
Chloride 5 ions are produced in the redox reaction between chlorine and hot aqueous sodium hydroxide. Oxidation numbers can be used to help balance the equation for this reaction. What are the values of P, X, and Y in the balance equation? A.
Mhm. Well, I always recommend my students to memorize both the disproportionate equations in the book. One is with chlorine and cold dilute aqueous sodium hydroxide, and the other one is chlorine and hot aqueous, hot concentrated aqueous sodium hydroxide solution. If you memorize both of them, any questions like this should not be a problem, and you won't even take more time than expected.
I think, sir, it's C.
Saad?
Yes, sir. It's C.
Yes, it is C. That is correct. Remember both the equations. First one is Cl2 plus NaOH, and it gives us NaCl plus NaClO plus H2O. Okay, and if you write this, the whole equation is balanced. The second one is Cl2 plus NaOH, and in this case, we have NaCl, though they have used the ionic equation, but this would give you a very good idea how that goes. So H2O, and of course, If C is correct, we are using this 3 over here, this 5 over here, this 1 over here. And in order to balance everything out, that would be 6 and of course 3. All right. So this gives the idea how it goes. Memorize both the equations. It would be really helpful for you. So 5.
Sodium azide is dissolved in water. Acidified silver nitrate is added to the solution and a white precipitate forms. Aqueous ammonia is then added to the white precipitate. The azide ion has similar chemical properties to the chloride ion. Which row of the table can be predicted from this information? Formula of the white precipitate, observation on adding aqueous ammonia. Dissolved in water, acidified silver nitrate is added to the solution and a white precipitate forms. Similar properties to the chloride ion. AgCl is a colorless solution, so a colorless solution forms, and the azide ion has similar chemical properties to chloride ion. So I think A.
Sir, A.
Perfect. Let's move on to 6.
An aqueous solution of a calcium compound is treated with a mixture of dilute aqueous nitric acid and aqueous silver nitrate. The resulting white precipitate dissolves when dilute aqueous ammonia is added. What is the relative molecular mass of the calcium compound?
So what's the amount of calcium?
40.
40.1.
40.1. That is right.
Sir, MR of nitric acid and MR of silver nitrate. इसकी रेशियो लेंगे?
No ratios.
No ratio.
Just jump on the conclusion which calcium compound is that based upon the facts given over here and find out its MR through periodic table. This is not a ratio question at all.
Okay, sir.
So सिल्वर का बार क्या होता है?
Silver? I really have no idea. But to my knowledge, you don't require it this over here. As I've already said, the facts given in this one predict which calcium compound is that and simply find its MR from the periodic table. Well, you might have to look up the periodic table for silver. You're taking quite some time, which is not advisable for this kind of question.
Sir, C.
However, your choice.
Sir, I'm confused.
Okay, Saad is perfectly correct. You can notice white precipitate is formed by a chloride compound. You acidified with nitric acid, you use silver nitrate, only chloride forms a white precipitate. To further clarify, that chloride precipitate would be dissolved when aqueous ammonia is added. So probably it was CaCl2. That's the only chloride calcium compound we can come up with. So that means 40 plus 35.5 plus 35.5, sorry, 40.1, not 40. The answer should be 111.1. So see, it wasn't a ratio question. Based on facts, you need to come up with a compound. And yeah, that was calcium chloride. Makes sense?
Yes.
Okay, you can never do the MCQs or the theory of chapter number 17 correct if you don't remember the points that were about practical portion. How do we detect chloride, bromide, or iodide ion? And we have done many questions related to that, and you fall for the traps. So try going for those things first, right? So just a quick review. Chloride ions give you white precipitate, okay? Bromide ions give you green precipitate, okay? And iodide ions give you yellow precipitate. You can also say pale yellow, that's fine. Now the chloride ions will dissolve in dilute NH3 aqueous, right? And bromide would dissolve in concentrated NH3 aqueous with sometimes some books say warming, some books don't say warming. Well, whatever the MCQ is, you can go accordingly. And this won't dissolve. Now, this makes it dissolve. Now, this makes it dissolve. But whether you use dilute or you use concentrated, whether you heat it up or you don't, it does not dissolve. Okay, so this gives us a clearly good idea that how this would work. Now, you need to remember these pieces of information exactly from those big diagrams in the book of the test tubes containing these colored precipitates and related information. Okay. If you remember this, many of the questions are going to be very easy for you because after every 1 to 2 questions, maybe 3 questions, you'll find a question related to precipitates or the usage of uh, silver nitrate or the use of aqueous ammonia after it. Okay, so getting back to 7.
Yes, sir. The solid sodium chloride and sodium iodide both react with concentrated sulfuric acid at room temperature. With NaCl, the products are NaHSO4 and HCl. With NaI, the products are NaHSO4HI, iodine, sodium, sulfuric, wait, this is sulfur dioxide, water, sulfur, and H2S. What is the best explanation for this difference in products? C.
Sir, C.
See, Good. Now, how come C? Now, previously I was
So,
discussing, yeah, go
that
ahead.
all the groups
Sure.
have better reducing agents.
Right. So previously I was saying as soon as you react NaI with H2SO4, now you need to clearly understand what I'm about to say because this is going to help you answer most of the MCQs related to the products with sodium iodide or any of the iodide ion based reactions with sulfuric acid. Now, when this reaction occurs, actually, that's not right. We need to put up an arrow. What happens is that you form NaHSO4 plus you form Hi. Now, the point is, H2SO4 is a very good oxidizing agent, good enough to oxidize Hi or HBr, but it never works on HCl. It's not good enough for that. What happens is that H2SO4 and Hi then further react. Now, H2SO4 is an oxidizing agent and Hi is a reducing agent. Now, the reducing agent actually is converted into iodine. Hence, this product, I've already catered these two products in the previous equation, so I'm not talking about that. Now, Hi, in which I is negative, goes to 0, which means it was a good reducing agent, so it itself oxidized by the loss of electron. I hope this explains the formation of iodine. But as soon as this is going to happen, remember, the opposite is also going to happen. If H2SO4 is a good oxidizing agent, it converts Hi into I2. Hi is also a reducing agent that converts H2SO4 further into two products, that is SO2 plus H2O. Now, H2SO4 has plus 6 charge on sulfur. SO2 has plus 4. Hi is such a good reducing agent that it doesn't stop over here. So further, it converts it into sulfur, which has 0 charge. So this was plus 6, then this was plus 4, then this was 0, and then this S is minus 2. It keeps on reducing that H2SO4 or even broken down products into further products. So we keep on getting more and more products, hence a big list in case of Ni. Does that make sense to you?
Yes, sir.
Yes, sir.
Okay, remember, Cambridge puts up the question in both ways. Cambridge can ask you about the oxidizing power of H2SO4, and which makes it actually capable of converting Hi into I2. Cambridge can ask you from a different version, the reducing power of Hi, which can convert H2SO4 into SO2, later on into S, later on into H2S, right? Because it works both ways. An oxidizing agent oxidizes the counterpart reactant, and the reducing agent reduces the counterpart reactant. So make sure you understand both versions, the version of the oxidizing agent or the version of the reducing agent, and you can answer both correctly. I hope that clears it out completely. So let's move on. Number 8.
The table shows some reactions of a white compound G. What could be the identity of G? Sodium nitrate is added to a solution of G followed by aqueous ammonia. A precipitate is formed which does not dissolve in the ammonia. So this is iodine. Solid G is formed with concentrated sulfuric acid. A mixture of gases is formed, including hydrogen sulfide. D. Sodium iodide.
That's it about you.
D delta.
Right, perfect. Okay, 9.
When concentrated sulfuric acid is added to solid sodium bromide, bromine gas is produced, along with a number of other products. However, when concentrated sulfuric acid is added to solid sodium chloride, only hydrogen chloride and sodium hydrogen sulfate are produced. What is the reason for this difference?
D delta.
Yes, Saiba. What do you think?
D.
Yes, D delta. Okay, volatility has nothing to do with it. Hydrochloric acid is not a weak acid. Sulfuric acid is actually acting like an oxidizing agent. So the only correct option would be D. Okay, so 10.
Aqueous silver nitrate is added to a solution of potassium iodide. Aqueous ammonia is then added. What would be observed? Silver nitrate is added to a solution of potassium iodide. A clean precipitate dissolves and reduces aqueous potassium iodide. A yellow precipitate. D. Delta.
And Saad, your choice.
Sir D.
Perfect. Okay, all right. 11.
When concentrated sulfuric acid is added to solid sodium chloride, HCl is formed but not chloride. When concentrated sulfuric acid is added to solid sodium iodide, I2 is formed. Which statement explains these observations?
Sir C.
No, Saad, C is not correct. Choose again.
Sir then A. Wait. Sir then it will be D.
Sulfuric acid is not a reducing agent. So it can't be C or D. You need to choose between A and B.
B.
Sir B.
B, very good. Sulfuric acid is an oxidizing agent, but chlorine ions are not easily reduced. Iodide ions are more easily reduced. So A cannot be correct because they have written instead of not the word more, and B is correct. C and D are both wrong because sulfuric acid is not a reducing agent. It's actually an oxidizing agent. So moving on, 12.
When concentrated sulfuric acid reacts with sodium iodide, the products include sulfur, iodine, hydrogen sulfide, and sulfur dioxide. Which statement is correct?
Sir C. Cat.
Yes, Saiba, your turn. And Prasad, you, let me tell you, this is not a disproportionation reaction. So it cannot be both oxidized and reduced for the same element. Choose again.
A.
Sir, I also choose A.
Right. Now this time you're both correct. Now let me clarify a little bit. B is wrong because iodide ions are reducing agents. They're not oxidizing agents. B is wrong because this is not a disproportionation reaction. D is wrong because sulfuric acid itself is the oxidizing agent. How would it get oxidized itself? It should get reduced. All right. So the only one correct is the hydrogen sulfide is a product of reduction reaction. Now the iodide ions are working as good reducing agents. Of course, they're going to reduce sulfuric acid, which is reduced into sulfur dioxide, then into sulfur, and then finally into hydrogen sulfide. So yeah, hydrogen sulfide is actually forming because of a reducing agent. So of course, it's undergoing the process of reduction. So A is the only correct option in here. Okay. So moving on, 13.
The powder is known to be either a single sodium halide or a mixture of two sodium halides. A sample of the powder was dissolved in water, aqueous silver nitrate was added, and a pale yellow precipitate was formed. When concentrated aqueous ammonia was added, the precipitate partly dissolved, leaving a darker yellow precipitate. What might the powder have consisted of? B.
What if I tell you it was a mixture? I mean, I'm
It
taking
wasn't
out options
Sir, D.
A and B. It's a mixture. It's not a single halide.
D.
What would you choose then?
Sir, D. Delta.
D.
D. All right. Try and understand the point that it's a mixture. Why? How did we know? It was a pale yellow precipitate. Now, pale yellow can just be iodide, understandable. Now, the precipitate partly dissolved and it gave a darker yellow precipitate, which means it was probably iodide in some other substance, whether it can be either white or it can be green, because of which we were having the pale look, which darkened after dissolving. So since we are using concentrated ammonia, it can either be chloride or bromide. Now, we don't have an option for bromide and iodide. We only have the option for chloride and iodide. D would be the only correct option because it is to be a mass and iodide. And along with it, it can be either chloride or bromide. So it's a chloride and iodide. D is the only correct option. Okay. So 14.
When chlorine reacts with hot aqueous sodium hydroxide, two chlorine-containing ions are formed. One of these is the chlorine ion. What is the other ion?
B.
But if I tell you we are only forming ions with the odd number of oxygen atoms, means I'm taking out both B and D. So which one would you choose out of A and C?
C.
Just like by you. I'm giving you this
C.
hint because I remember uh, evenly mentioned oxygen atom ions. Ions that contain even number of oxygen atoms are not a part of your book. So whenever it's chlorine or any other halogens reacting with sodium hydroxide, whether it's cold dilute or whether it's hot concentrated, always an ion forms which has odd number of oxygen atoms. So either A or C. So yes, Laiba, what did you say earlier?
C.
C. All right, C is correct. So let's move on to 15.
In a series of 9 experiments to test the reactivity of the halogens, an aqueous solution of each halogen was added to an equal volume of an aqueous solution containing halide ions as shown in the table below. The 9 resulting mixtures were then shaken with hexane. The 9 tubes were corked and left to stand so that the aqueous and organic solvents could separate into layers. How many test tubes contain a purple upper layer?
This is a very good question. And we're not going to just finish it up with the choice. You are going to mention to me, uh, as per the choice, which exact experiment numbers were those.
So D delta.
Okay, whichever option you choose, be ready to answer the next question.